This is the review for the quizzes that we took in class during the week of October 26th. I have all the questions set up right here, which I'm going to go through one at a time. I'm going to go through them somewhat swiftly, but I might spend some more time on other problems. For example, with this first problem, the intention of this problem was to identify the type of form of the quadratic that you had. Um, just because a quadratic is in a different type of form doesn't mean that it is no longer a quadratic. For example, this first choice right here, the one that I'm bringing my mouse over with x minus p, x minus q, that is the intercept form of a quadratic. And then the answer to this particular question is this one right here. We put this into our notes last week. That is the vertex form of a quadratic. They're still quadratics, they just look differently and tell you different types of information. But now, number two, they're asking to find the vertex. So I'm going to write down this problem for number two. It is y equals negative 2x squared plus 4x plus 3. Switching over here. They want me to find the vertex. The vertex formula is negative b over 2a. Should already have that written into our notes as well. Plugging in the values for b and a, we end up with the following calculation. Please be very careful with how you simplify this problem out. If you try typing it into the calculator, there's a high chance that some people will make a mistake. But they wanted the vertex because if you look at the choices, each choice is an ordered pair. In order to get the y value, because this is the x value of the vertex, in order to get the y value, you simply have to plug the x value back in, which in this case, if you did it correctly, would spit out a 5, which means that the vertex of this particular problem is 1 comma 5. You can see that right there. For number 3, they want to know what is the vertex of this graph. Now, there's no work to be done. It's just visually identifying what that vertex is. Now, parabolas can open up, parabolas can open down. In this case, it's opening up, so the vertex is this minimum point that my mouse is pointing at, which is 3, comma negative 1. You can see that there. Switching to number 4. Now, they want you to solve this problem. Solving this problem could be done in one of two ways. You could solve this problem by factoring, or you could solve this problem by using the quadratic formula. Now, for the sake of argument, I'm going to solve this by factoring, and I'll use the quadratic formula for a different set of problems a little bit later on. But looking at number 4, if I'm going to multiply a times c, going through the Tucker method, I get negative 24. My two magic numbers, which have to multiply to negative 24 and add up to that b value, are 6 and negative 4. Technically, you don't need a t-chart here because it'd just be a and a because it's 1a squared. And I would get a plus 6, a minus 4 equals 0. But again, the problem is asking for you to solve, which means we do have to continue to get an answer of negative 6 and positive 4. You set each of those equal to 0. A plus 6 equals 0. Solve, you get negative 6. A minus 4 equals 0. You solve, you get positive 4. And if you look at the choices, there it is right there. Negative 6, positive 4. I get rid of that. For number 5, they just wanted you to determine the values of A, B, and C. But the only way that you're going to identify the values of A, B, and C correctly is if you get one side of the equation equal to 0. Now, clearly, A, bringing my mouse over, A is positive 4 if you leave it on the left side, which is what they're hoping you do. Negative 8 is your B value. But then you're going to have to take that 3 and subtract it from both sides to get one side equal to 0. So it should be 4, negative 8, and negative 3. There's that choice right there. For number 6, again, I left the answer thing on. For number 6, they want you to solve by factoring. Now, I will do this one by factoring simply because there is a nice little trick that can be done. I call it a trick, but in reality, it's one of the steps of the Tucker method. I'm going to be writing down for number 6, 5x squared minus 35x plus 60 equals 0. The first step of the Tucker method is always to check for a greatest common factor. In this case, it's got to be 5. If I take out that 5 as a factor, it leaves me with the following. That's a much nicer quadratic to deal with. If I did a times c to get 12, my two magic numbers, they got to multiply to a positive but add up to a negative. So they both have to be negative, multiplying to a positive, adding up to a negative. I'm going to bypass the t-chart because that's not needed here. Now I still have to solve. This is where you would set each of your factors. You have 3 factors. You would set each of them equal to 0. 5 equals 0 makes no sense, so I'm just going to cross it out. But this is where you get an answer of positive 3 and positive 4. Taking a look, you can see, boom, positive 3, positive 4. They did ask to solve by factoring, so I just complied by taking out the greatest common factor. It makes your life a lot easier. Let's take a look at number 7. Solve by using the quad formula. Now, again, I'm going to comply with what the problem wants to show you exactly what is needed here. 15x squared plus 22x equals negative 8. Now, as many people would have surmised, you need to get one side equal to 0, meaning it really is 15x squared plus 22x plus 8 equals 0. You got to make sure you get one side equal to 0, otherwise the quad formula is not going to work. Your b squared minus 4ac, since I'm using the quad formula, I might as well immediately do the discriminant. 22 squared minus 4 times 15 times 8. Grabbing my calculator, just to kind of knock that out real quick. 22 squared minus 4 times 15 times 8 gives me a positive 4. That is the value of my discriminant. I'm going to slide it over here. Negative b plus or minus the square root of my discriminant over 2 times a. I can't leave it like that. If you look at the choices, each choice is a nice looking fraction. So I'm going to have to simplify this thing down. It really is negative 22 plus or minus 2 over 30. Negative 22 plus 2 is negative 20 over 30, which is negative 2/3. And negative 22 minus 2 is negative 24 over 30, which reduces to negative 4 over 5. Those are my two answers. Looking at here, it should be this last one, and it is clearly. Taking a look at number 8. Again, another quadratic formula problem. And I do ask you to be very careful with how you're doing this, only because your calculator, if you do not use it correctly, if you type it in wrong, is going to give you the wrong answer. They want you to find the solutions of this. Since they want me to use the quad formula, I'm going to use it. 8 squared minus 4 times a times c. I'm going to go to my calculator for a little 8 squared minus 4 times 3 times negative 1 gives me a 76. That's my discriminant. Negative b plus or minus the square root of the discriminant over 2 times a. 2 times 3 would give you 6. Now, if I was going to leave the problem like that, I mean, in most cases, I probably could. It is possible to simplify this because you can break up that 76. I believe you can divide it by 4. Yeah. So you could actually break it up the square root of 4, the square root of 19, and then begin simplifying things down. But if you, oh, and there's the bell. They left the bell on. But if you look at the choices that they give you, clearly they're decimal choices. So we have to be careful with how we do this. Now, you could figure out what the square root of 76 is. I mean, you know what? Let me just do that for the sake of argument. In class, I try typing in it all at once, but let me just try to figure this out piecemeal. It really should be negative 8 plus 8.72, if I were to round it, close parentheses, divided by 6. Now, that's a rounded number. I'm not a huge fan of that. And you can see right here, that is the rounded number. 0.12 is what that rounds to. You could round it like that if you wanted to. Personally, I would prefer not to. If it were me, I would try to get that decimal, which obviously still rounds to 0.12. If I were doing the other calculation, negative 8 minus 8.72, negative 2.79, I guess it rounds to, or negative 2.8. You can see that right there. There's the negative 2.78. You can see when I click this, it clearly gives that choice as the answer. To me, if it's a decimal, you could do that rounded version, the one that we did with the 8.72. Or you could try to get the exact answer by putting in that square root of 76. Either way, it works for me. So I would say, now the exact decimal would be 0.1196. And let me type this in. And negative 2.786. Those would be the exact answers, or the more accurate answers, I should say. But then if you wanted to round that square root of 67, getting a 0.12 and getting a negative 2.79 even, is perfectly acceptable as well. I would accept either answer. You just have to be careful about it. Looking at number 9, asking you to factor. Now again, this problem is not asking you to solve. It's asking you to factor. It's not asking for a solution. 10x squared plus 15x minus 5. Right off the bat, I notice a greatest common factor of 5, which I'm going to take out. And then I'm going to begin the Tucker method. Well, technically, step 1 of the Tucker method is GCF, but moving on to step 2, a times c gives me negative 2. Two numbers that multiply to negative 2 and add up to positive 3. Negative 2 and 1 don't work. 2 and negative 1 don't work. I can't do it. It's not possible. Oh no. But none of the choices said not factorable. Technically, since that quadratic is not factorable, what I just circled is my answer. I was able to factor out the 5 as a GCF. It counts as factoring. But the 2x squared plus 3x minus 1, as you can see here, it cannot be factored. Looking at number 10, factor completely. I'll do this one on the same page. X squared minus 36. The b value is missing. Technically, the b value is 0. A times c is negative 36. 6 and negative 6 are my magic numbers then. Because they add up to 0, they multiply to negative 36. I'm going to bypass the t-chart because it's a 1x squared. That's all I can do. Now, a lot of you might be able to recognize that right off the bat because this is the difference of two squares. But I decided not to teach that formula because I don't like learning a billion formulas. I like maybe 1 or 2 formulas. Another factoring. This problem, I can see right off the bat it's a 1x squared, so that makes my life a bit easier to do a 1x squared. A times c is 8. Two numbers that multiply to positive 8, but add up to negative 6. They just want me to factor, right? Yep, just factor. There it is, the top left one. You can see it right there. Always do what the problem, there's a bell again. Always do what the problem is asking you to do. Don't do more than what they ask. Solve for the values of x. Now, this problem clearly does not look like other problems that we've seen. This problem is already written in what we call intercept form. That was one of the first forms. The first question asked for vertex form, but one of the choices was intercept form. It's factored form. And when you already have something in factored form that is being multiplied together, set equal to 0, you can immediately begin solving it, where you get your two answers. You don't have to factor because it's already been factored for you. -2 and +3. Now, this is a little weird because they gave it to you in what they call set notation, not ordered to pair or anything like that, or just listing them out. But you can see -2 and +3 as your two solutions. Number 13. Saw a few hiccups on this problem. You weren't really given a direction like, hey, solve this. But no, they didn't say that. Instead, they had x squared equals 25, and they basically just left you to do it. You can do this any which way. Some people just square rooted and got an answer of 5, but 5 was not the only answer. There were two answers to this. You could do the quad formula. You could factor. In fact, I'm going to do the quad formula here, just for fun. B squared minus 4ac should be 0 squared minus 4 times 1 times -25, which would be a positive 100. That is my discriminant. Negative b, I know that won't do anything, plus or minus the square root of the discriminant over 2 times a. This would really be plus or minus 10 over 2, which is just positive or -5. Now, you would get the same exact answer by factoring. I just wanted to show you that the quad formula clearly does give you the same answer. Number 14, what is the name of a quadratic graph? This was just kind of a little bit of a gimme. Obviously, the name of the graph is a parabola. A vertex is a point on the graph. The axis of symmetry is what splits it down the middle. A 0 is a solution, but the name of the graph is a parabola. What are the dimensions of the picnic blanket? Now, again, they don't tell you how to do this problem. They don't. Instead, they leave you to realize that in order to figure out the area, or the dimensions, I should say, the dimensions of the picnic blanket would be the length times the width. The length times the width would give you the area. The area is that quadratic. So based on that, and based on the choices that they gave you, clearly I'm giving away the answer. But based on all of that, you would have to factor. Your a times c is -44. I'm going to have to do a t-chart here because it's a 22x squared. Your two magic numbers look like they're going to be 4 and -11 because they got to add up to -7 multiplied to -44. Let's do a little t-chart going on here. 4 and -11 both can simplify. Divide by 2, divide by 2, divide by 11, divide by 11. The negative stays on the bottom. 11x plus 2, 2x minus 1. That would be the same Tucker method that we've seen over and over and over again, which obviously I gave away that answer before. Get rid of that. 16. A brick falls from the top of a building. The equation, that thing, represents the height of the brick in feet after t seconds. How long will it take the brick to reach the ground? This is number 16. H equals -16t squared minus 21t plus 200. Let's see what we got going on here. Wait, going back a little bit, they want to know when will it reach the ground, round to the nearest tenth. When will it reach the ground implies that I let h equal 0. You want to draw a little picture of this? You could. There's 200 feet. There's the brick. And there's when the height is equal to 0, when it hits the ground. That's what I have to solve. Now, they did imply that I had to round the answer, so I'm pretty confident that I'm going to have to do the quad formula. Because factoring typically get you nicer looking answers, but I vaguely remember this one kind of being a bad answer. But as I always say, factoring, if it doesn't work, the quad formula will work all the time. There it is. 13,241 is my discriminant. Negative b, notice how I wrote that in, plus or minus the square root of 13,241 divided by 2 times a. Let's break this down piece by piece. This really should be 21 plus or minus that terrible looking number over negative 32. Now again, if you wanted to type that whole thing in at once, that's fine. If you wanted to evaluate the square root of 13,241 right off the bat, that's fine, and you use that rounded number. Personally, I'm going to do this. Second enter, bring it back, change it to a minus. I get two answers. I get an answer of negative 4.25, and I get an answer of positive 2.94. Now that makes sense because obviously the other half of the parabola would produce a different answer. That would be the negative answer. But the positive answer, the 2.94 seconds, is what I'm looking for. Now, this problem did say round to the nearest tenth, meaning I'd probably round to 2.9, which is clearly what this thing has. Number 17, name the zeros. Now that, naming the zeros, they're ordered pairs. It looks like positive 4 is definitely a 0. That one works. However, there are two zeros, and that origin right there has to be that one, which clearly you can see they chose it. Number 18, name the zeros. Well, to be very, very clear, this is the vertex, what I just highlighted. This is the y-intercept. But the answer is actually no solutions. There are no real solutions. I wanted to emphasize that. There are no real solutions. And you can see that here. Number 19. The length of a rectangle is 5 feet less than its width. If the rectangle's area is 84, find the dimensions. Okay. I'm pretty confident that I can eliminate that negative answer. You can't have negative length or negative feet in this thing. So let me just draw a little rectangle and then see how I'm going to label it. The length is 5 feet less than the width, and the area is 84. Okay, I got that. Length times width is equal to 84. That's the setup. Just like the project we did, I'm going to subtract 84. Save myself some time. I need to figure out this magic number now. There we go. 12 and 7 look like they work, but one of them's got to be negative. It's got to be the negative 12. W minus 12, W plus 7. I was trying to find two numbers that multiplied to negative 84, and they added up to negative 5, as you can see there. So my answer, this answer would produce a negative answer, which again can't happen. The width has to be equal to 12. Now, given that the width is equal to 12, that means that the length has to be 7, positive 7, because you plug the 12 in right there. 12 is feet, I think. Yeah, 12 feet by 7 feet, which has to be the bottom right answer. Yep, there it is. Number 20, another word problem, because I love word problems. You should know that about me by now. Your nephew is standing on his deck, which is 4 feet off the ground. He tosses his toy up in the air. The equation models the toy's height. How high is the toy after 1 second? Now, if you're going to visualize this, what is he, 4 feet off the ground? 4 feet. He tosses the toy. I don't know how high or how low this kid tosses the toy. There it is right there. Let me write down the equation. H equals negative 2 t squared plus 7t plus 4. And they want to know, how high is it off the ground after 1 second? All right, just plug in a 1. This is what we've been doing with these problems over and over again. And try and do it without a calculator here. 9. Looks like 9 feet. Now, I have no idea whether or not that's the vertex. It probably isn't the vertex, but I can double check that. Negative b over 2 times a. No, the vertex would be 1.75. Yeah, and the highest height the vertex that it would reach is actually over 10 feet. But looking at these choices, how high would it be after 1 second? You can see that 9 feet is clearly the answer. I would definitely make sure that you put units on that, because just having a 9 is not going to cut it, as I did here. Number 21. Fireworks are fired from the roof of a 100-foot building. There's the equation that models the situation. How high did the fireworks get? So if they're saying how high do they get, they want the vertex. You need to be careful with how you do this calculation. How high do they get? Negative b over 2a will give you the highest or lowest point, depending on if it opens up or down. In this case, it's opening down 2.625. Now, let me go back to the question real quick. How high do they get? 2.625 is not my answer. It's a correct number in the problem, but it's not my answer. You can even see 2.625 is one of the choices, but it's not my answer. That's how long it takes for the firework to reach its highest point. Now, in order to find its highest point, in order to find how high this rocket actually gets, I'm going to have to take that number and plug it inside. Just see real quick what this thing actually gets me. Negative 16, 2.625 squared plus 84, 2.625 plus 100. Looks like 210.25 feet. And I believe, click, there it is. The answer. Number 22. I already showed the answer. Jason launches a rocket. The equation can be used. How many seconds will it take for the rocket to reach the ground? Now, when you have a problem like that, when it reaches the ground, you know what the height is. This is number 22. H equals negative 16t squared plus 288t plus 8. And they want to know how long it takes for the rocket to reach the ground, meaning I am going to put a 0 in for H. Flip back. There it is. Now, if you notice, I'm going directly for my quad formula. I don't feel like dealing with such large numbers in the Tucker method. Sometimes I really don't feel like dealing with them. And to me, using the quad formula just feels like a safer bet. I'm going to double check that number in a moment. 83,456. Let's double check that. No, we're good. That should work. It's not going to be a perfect square. I know that. You can see that right there. But I'm going to go ahead with the rest of the quad formula. Negative b plus or minus square root 83,456 over 2 times a. I'm going to skip a step and put negative 32. I'm going to get 2 answers, as we have been getting all day. Negative 288 plus the square root of 83,456 divided by negative 32. You can see it gets me an answer of negative 0.03 if I rounded it. Do it again, second enter, with a minus 18.03 seconds. Was it a rocket? Yeah, he launches a rocket. How many seconds will it take for the rocket to reach the ground? Clearly, it's not the negative answer. It's got to be 18 seconds, as you can see right there. Finally, number 23. Number 23 doesn't require much in terms of writing, but I am going to write something regardless. I'm going to write for number 23 what I see on the graph right here. I'm not going to copy the graph, but I'm going to do this. I can see visually an x-intercept of -3 and an x-intercept of +8. And I want you to notice this. The question is asking for the factors. It's asking for the factors. Now, if the x-intercepts, which are also known as the zeros, which are also known as the roots, which are also known as the solutions, if you were to work backwards, you would end up with the answer of -3, but then the step before it would be this. You would end up with an answer of +8, but then the step before it would be this. And the step before getting these two factors would be this. And then if I multiplied them back together, I'd get this. This is working the problem backwards. Working the problem backwards. You'd start with a quadratic, you'd factor it, you'd set each term equal to 0, and then you'd get your solutions. And you would deem those solutions the x-intercepts of the graph. However, this problem wanted the factors. That is what these two terms are. X plus 3 and x minus 8. They are not your zeros, roots, or solutions. They are your factors, which is why those two were the ones that worked. Now, this review is meant to be worked in conjunction with the edge elastic major that you currently have. If you have any questions, please make sure you are contacting me. Thank you.